So, to help us understand acids and bases, or rather to be able to quickly describe whether a solution is an acid or a base, we have something called the pH scale, which is a measure of the acidity or the basicity of a solution. And what it is, it's a mathematical calculation for how much hydrogen ion or how much hydroxide ion is present in a solution. Now, the ranges are typically between 0 and 14, but there are no rules that say that you can't have negative numbers or numbers higher than 15 or than 14. It's just most of the things we encounter are within this range. Now, on this scale, pH 7 is the midpoint, and it's considered neutral. Water is considered neutral with a pH of 7. And that's because if I think about water and the way that it would dissociate on its own, then it would produce one hydrogen ion and one hydroxide ion when it dissociated. Since it's producing equal amounts of hydrogen ion and hydroxide ion, it will numerically calculate out to a pH of 7. And I'll show you that a little bit later on. So this midpoint, this pH 7, is considered neutral. It is neither an acid nor a base. As I add an acid to water, the amount of H plus is going to change, and I'm going to start increasing the amount of H plus relative to the OH minus. What this is going to result in is the pH dropping, and the pH is going to get slower and lower and lower. And the lower the pH gets, the more acidic that solution becomes. And so we can see things like the battery acid in a car is very, very, very acidic. And even the stomach acid in your stomach is very acidic. And it has to be because that acid breaks down the food that you eat so that you can uptake the nutrients. Now, on the opposite end, if I add a base, then what I'm adding is more hydroxide, and this means the amount of hydroxide is going to be larger. And so there's going to be less of the H plus around, and this results in an increase in my pH. And so the higher the pH gets, the more basic the solution is. And so when we look at something like drain cleaner, like Drano, we are all the way at like 14 versus something like soapy water, which is around anywhere between 8 and 12, depending on what kind of soapy water you have. So bases are anything with a pH of 7 or greater. Now, this idea of pH is actually a numerical calculation. You calculate the pH by taking the negative log of the hydrogen ion concentration. And we're going to keep it simple today. We're just going to practice getting pHs if you know the hydrogen ion concentration. On a calculator, log is a function that deals with exponents. And so this is the Google calculator, and you can see the log button is right there. So if I want to calculate the pH of a solution, all I need to do is know that hydrogen ion concentration and plug it into a calculator. So here's one where it says, what is the pH of a solution that has a hydrogen ion concentration of 3.6 times 10 to the minus 6? And I'm simply going to go to the calculator and type it in. So go over to Google Calculator. I'm going to clear this one out. And we have negative log of 3.6 times 10 to the negative 6. 3.6 times 10